GCE Advanced Level Chemistry Practical Series Experiment number 40. Preparation of the standard silver chloride electrode. When it comes to talking about reference electrodes, we learn about two different types of reference electrodes: primary reference electrodes and secondary reference electrodes. Under secondary reference electrodes, we talk about two types of metal insoluble salt electrodes. One is calomel electrode, the other one is silver chloride electrode. So in today's experiment, we are going to learn how to prepare our silver chloride standard electrode. Now, let's move on to identifying the different reagents and equipment we will be using for this experiment. Students, now let's take a look at the chemicals and the equipment we will be using for this practical. We will be using potassium chloride, and students, we have used this potassium chloride to prepare 3 moles per decimeters cube concentrated potassium chloride solution. So in this volumetric flask we have here, we have 3 moles per decimeters cube concentrated potassium chloride solution. And we will be using agar, we will be using concentrated nitric acid. We have a wash bottle filled with distilled water. We have a spatula here which we'll be using today. And we have a silicone sealer. So we use this silicone sealer to seal off our silver chloride electrode today. So we'll be using this silicone sealer. We'll be using these wires to connect the electrodes to the power supply. We have here sandpaper. We'll be using this glass tubing to prepare our silver chloride standard electrode. This is the silver wire we'll be using to prepare our silver chloride standard electrode. So this wire is made of silver. This is the silver wire we'll be using for this experiment. And for this experiment we need a graphite electrode. So what we have here is graphite rods that we use for pencils. So this is graphite pencil rods. So these pencil rods which are made of graphite can be used as a graphite electrode. We'll be using beakers, and over here we have our direct current supply or direct power supply. So this is a setup that we have made with the use of two 1.5 volt batteries. So this is capable of providing a direct current to the setup we'll be using in a while. So students, these are the equipment and the chemicals we will be using for this experiment. Now let's move on to actually conducting our experiment. Students, in this experiment we are going to observe how we are going to prepare a reference electrode. There are mainly two main kinds of reference electrodes: primary reference electrodes and secondary reference electrodes. A primary reference electrode is an electrode that is said to be having a potential of 0. So if you take hydrogen or standard hydrogen electrode, it has a potential of 0, or we actually take it to be having electrode potential of 0. The standard hydrogen electrode is always used in conjunction with another electrode. We can use a secondary electrode which we don't know the electrode potential of, And if you use the standard electrode, which is the standard hydrogen electrode, along with another electrode which you don't know the electrode potential of, if you connect them to a voltmeter, or more accurately known as a potentiometer, we will be able to calculate the electrode potential of the unknown electrode. So students, a reference electrode is usually used to calculate the electrode potential of another electrode with an unknown electrode potential. So when it comes to a primary reference electrode, a primary reference electrode such as the standard hydrogen electrode, by a convention we actually take its electrode potential to be 0. By a convention we take the standard hydrogen electrode's potential to be 0 volts. And there are secondary reference electrodes. There are mainly two types of secondary reference electrodes that we use. One is calomel electrode and the other one is silver chloride electrode. Now in this experiment we are going to be looking at how to prepare a silver chloride standard electrode. So when it comes to secondary reference electrodes have a well-known electrode potential. So based on the concentration of the electrolyte we are using, we know the electrode potential very clearly. And they are very stable when it comes to their electrode potentials. They are not undergoing any change when we are measuring the electrode potential of another electrode compared to the reference electrode. So their electrode potential is usually quite stable. Apart from that, when it comes to secondary reference electrodes, apart from them having a good stability when it comes to the electrode potential, when it comes to silver chloride electrode, it has good stability when it comes to slight temperature changes as well. So therefore, silver chloride reference electrode is a very convenient reference electrode to use, unlike other primary reference electrodes such as the hydrogen or standard hydrogen electrode. Standard hydrogen electrode is not easy to use. However, when it comes to standard silver chloride reference electrode, it is easier to use than that. And when it comes to the cost of manufacturing such a electrode, you will see it is not going to be that high as well. So we use silver chloride reference electrode when it comes to many of our potentiometric analysis. So this experiment revolves around how we are going to prepare this silver chloride reference electrode. So one of the most important parts of the silver chloride reference electrode is this silver wire that we have here. And students, when you're using a silver wire for this experiment, you have to make sure that it is having a clean surface where the silver metal is exposed on the surface. So to make sure the silver metal is or this particular wire is quite clean and it is exposing the silver metal onto the surface, we will be cleaning this with the use of a sandpaper. So we will place the sandpaper like so, and we will clean it really well. This will make sure that the surface of the silver wire is adequately cleaned. So this is a physical method of cleaning the silver wire. We can use a chemical method as well. Now after cleaning this silver wire like so, we can clean the silver wire with the use of nitric acid as well. So we can clean the bottom end, especially the end which we'll be using for preparing our silver chloride standard electrode. We can clean that area with concentrated nitric acid, and then we can wash it with distilled water. So let's proceed to do that. Now we will wash it with some nitric acid. We have our concentrated nitric acid here, students, and when you're handling concentrated nitric acid, please be careful as it is corrosive. We don't want the acid to come into contact with your skin. So we will take our silver wire. We'll take a small amount of concentrated nitric acid here, and we will wash the silver wire with concentrated nitric acid. Now, after washing it with nitric acid, we can proceed to wash it with distilled water, and once we do, we can see our silver wire is completely cleaned. So the silver wire is completely cleaned once you wash it with concentrated nitric acid and then with a little bit of distilled water. So we have now cleaned our silver wire. We can place it aside. Then we can proceed to remove concentrated nitric acid from the setup. And now we are going to coat this silver wire with some silver chloride. So right now what we have is just the silver wire here. We need to coat this silver wire with silver chloride so that when we are preparing our silver chloride standard reference electrode, we have both silver and the silver chloride we need on this silver wire. So now we are going to place the silver wire aside, and we will take another beaker, and to this beaker we will measure 20 cubic centimeters of 3 moles per decimeters cube potassium chloride solution. We have measured 20 cubic centimeters of potassium chloride solution. And now we will transfer this 20 cubic centimeters of potassium chloride into a clean beaker. And then we will measure 40 milliliters of distilled water . Now we have measured 40 milliliters of distilled water, and we will be transferring this 40 milliliters of distilled water into our potassium chloride solution to form a bit of a dilute potassium chloride. So now students, after preparing this dilute potassium chloride solution, we will be using this solution and we will be electrolyzing this solution with the use of a direct current and this silver wire and the graphite rod that I showed you earlier. So we have our direct current supply, we have our positive end and the negative end over here of the direct current supply, which is indicated here, positive end on my left hand side and the negative end on my right hand side. We will connect these two wires. like so. And to the positive end, we will connect our silver wire. We'll set it aside for the time being. And we will take a graphite rod and we will connect the negative end to our graphite rod, and we will then place them both in this electrolyte that we have here, electrolyte solution we have here. Bear with me a second, students. It's easier if we connect it like so. You can see already the silver has started to change its color, right? But we will dip it again. You can see very clearly how the silver wire is changing its color. You can see there are gas bubbles forming at the graphite rod. The gas that is formed here is hydrogen, and you can see the silver wire is changing its color. You can see silver is now changing its color. The more I dip it, you can see if I dip it a little bit more, even that region will be changing its color. So we will keep it like this for a while until enough silver chloride is deposited on the silver rod. Now students, as you can see that there is a reaction taking place here, and this reaction produces a silver chloride layer on the silver wire, and at the graphite electrode hydrogen gas is evolved. So we need to let this reaction run for a couple of minutes until sufficient amount of silver chloride is deposited on the silver wire. So we will allow it to get deposited, and we will return to you after sufficient amount of silver chloride is deposited on the silver wire. Now students, in this particular process, what is happening is when we connect the silver wire to the positive terminal of the direct current supply, the silver wire will release electrons, or silver will release electrons and will turn into Ag plus or silver plus ions. And so the silver wire will slowly turn into silver plus ions and will release silver plus ions into this medium. And as soon as the silver wires enter the medium, the solution contains chloride ions. So the silver and the chloride can form a precipitate, silver chloride precipitate. So on the surface of the silver metal, we will see the silver chloride precipitate formed as, in this case, a brown color layer. But if you see, when you observed earlier, it appeared to be quite a bit of a darker color. So there will be a brown or dark brown color layer appearing on the silver metal as silver chloride gets deposited on the silver metal. So when the silver metal is connected to the positive terminal, electrons are released from the silver metal. So basically silver solid turns into silver plus and an electron is released. So these silver plus ions come into contact with the chloride ions in the medium, and on the surface of the silver metal where the silver ions are actually released, they will come into contact with chloride ions and will form a silver chloride layer on the silver metal surface. So this is what happens when we connect the silver metal to the positive terminal of the direct current. What happens when you connect the negative terminal to the graphite rod? So the graphite rod is now going to be negatively charged as it is connected to the negative terminal of the direct current supply, and it will attract the positive charge ions in the medium, and H plus ions are present here in the medium that can actually undergo a reduction. Potassium ions and silver ion concentration is not sufficient enough for silver ions to undergo reduction. However, when it comes to H plus ions that are present in the medium, they are capable of undergoing a reduction by accepting electrons that are abundant on the graphite rod when we connect the graphite rod onto the negative terminal. So it has an adequate amount of electrons on it, that is why it is negatively charged now. So when H plus ions come into contact with the graphite rod, it will take electrons from the graphite rod, and H plus will turn into H. As you know, hydrogen doesn't stay as atoms, so two hydrogen atoms get together and will form hydrogen molecule. So two H pluses will receive two electrons to form a hydrogen molecule. So that is why we saw earlier around the graphite rod we saw gas bubbles forming. This is due to hydrogen being formed around the graphite rod. So in this way the circuit is complete, and when we allow this setup to run for a while, you would notice there will be sufficient amount of silver chloride deposited on the silver rod. So at this point you can actually take the silver rod out and make our standard silver chloride reference electrode. So we will allow it to run for a while, and then we will come back and move on to the next step. Now students, we have allowed this reaction to run for a while. We can see when you take it out that this section of the silver electrode, so there is a small brown black color coating that you can see over here. So we have now sufficiently coated the silver wire with silver chloride like this. We will keep it aside for a while. And we'll remove the setup from here. Now students, we'll be moving on to the final bits of preparing our solid silver chloride reference electrode. So let's move on to the last step now. So students, we observed how the silver wire is coated with silver chloride. Now we are going to move on to use this silver wire and produce our silver chloride standard reference electrode. So in order to do that, we need to prepare a agar solution, and then we need to close off one end. We need to close off one end of this glass tubing with our agar solution. So the next step of this process is to do that and then fill this glass tube with 3 moles per decimeters cube concentrated potassium chloride, and then we will insert our silver wire, which is now coated with silver chloride, into this glass tube, and we will seal off the other end using our silicone sealer. And then after that, we have completed making this solid silver chloride reference electrode. So up next is that step. So we will now move on to that step. Now we have in front of us some boiling tubes and a Bunsen burner, and we have agar and potassium chloride solution. So students, we are going to use this agar powder and this potassium chloride, 3 moles per decimeters cube potassium chloride solution, and we are going to prepare an agar gel. And using that gel, we will seal off one end of this glass tube. So to prepare our agar gel, we will take this agar powder we have here, and we'll take a small amount of this agar powder into a plastic spatula like this, and we can add it to a boiling tube like so. And then we will not add water to this. Instead, we will be adding a small amount of 3 moles per decimeters cube potassium chloride. We will be adding potassium chloride solution to dissolve this agar. And we would need the help of a Bunsen burner as well. We'll mix it really well, and we'll add a little bit more water. Right, so now we will heat this agar solution to form our agar gel. So we can use our Bunsen burner and we can turn it on. All right, and using a boiling tube holder, we can heat this agar mixture, agar and potassium chloride mixture here, like so, until all of the agar is dissolved. Right. Now, students, we can take our glass tubing that we have here, and one end of the glass tubing should be inserted inside our agar gel that we have prepared here, and we can keep it like that for a while until it solidifies, like so. Then we have to leave it overnight for 24 hours so that we form a good seal at the bottom of this glass tubing. So we will allow it to settle for 24 hours. We will show you how the bottom of the glass tube is sealed off with agar. Students, now we have allowed the agar gel to cool down for over 24 hours, and we have the agar gel that we prepared yesterday over here, and we'll now remove our glass tubing from this agar gel, and we'll observe whether we have actually prepared a glass tubing with a agar gel seal correctly. So you can see at the bottom of the glass tubing we do have a agar gel that is sealing off the bottom of this glass tubing. So we have now properly sealed off one end of this glass tubing with this agar gel. So keep in mind, students, this agar gel was prepared by dissolving the agar powder in 3 moles per decimeters cube concentrated potassium chloride. So this particular small layer of agar gel will eventually act as a solid internal electrolyte as well as a ion diffusion membrane, or in other words, this small section of our AgCl in our standard silver chloride reference electrode will act as a salt bridge when we are using this silver chloride reference electrode. So now that we have sealed off one end with agar, we can move on to getting our silver wire prepared for this particular setup. So we have to insert our silver wire like so, and we have to make sure that there is a section of the silver wire that is going to be coated with silver chloride, and then there's another section of the silver wire that is not coated with the silver chloride. And then we will be inserting this silver wire after filling this glass tube with potassium chloride solution that we prepared earlier, and then I will be sealing off this tube with some silicon sealer. But before sealing it off with some silicon sealer, we have some adhesive glue that actually provide a good sealing effect to this silver chloride reference electrode. So we will take this adhesive sealant and we will place it like so on the silver wire, and then we'll keep it aside, and then we have to very carefully fill this glass tube with 3 moles per decimeters cube concentrated potassium chloride solution. We have a dropper that we'll be using for this purpose, and we have our potassium chloride solution that we have prepared previously, and with the help of a dropper we are now going to fill this glass tube with potassium chloride solution, making sure that there aren't any air bubbles in it. You have to make sure that there aren't any air bubbles. If you have air bubbles, this will not be very successful. Now we are going to fill this glass tube with potassium chloride solution. Make sure as you fill this glass tube with potassium chloride solution that there won't be any air bubbles in it. You can see that there are no air bubbles in this region of our silver chloride standard electrode that we are preparing here. So this section is filled with 3 moles per decimeters cube concentrated potassium chloride solution, and at the bottom what you have here is a agar cap, actually a small layer of agar gel, which will act as a salt bridge when we are done with preparing this silver chloride reference electrode. If you want to add a bit more potassium chloride solution, you can do that. Right. Now students, after filling it with potassium chloride, we can now move on to inserting our silver wire. You can see this one section of the silver wire is dark brown in color. The other section is silver in color. This dark brown section indicates that on the silver wire there is silver chloride deposited on it, and this is the section of the silver wire that is not deposited with silver chloride. And now students, to see these two sections very clearly, you can see when you are comparing it against this white color background, the front end is going to be brown in color. That is because we have deposited silver chloride on the front end of this particular silver wire that we have. And then the second section is going to appear silver in color. So the silver color section is there due to silver metal being exposed properly. So when you don't have any silver chloride coated on the silver metal, silver wire will appear a silver color. So now we will be inserting this silver wire coated with silver chloride into our glass tube like so, and we will seal off the other end. And we have now sealed it off with the use of some adhesive glue, and we can now use this silicone sealer to seal it off properly. Now students, we have sealed off the top bit of our silver electrode with the use of silicone sealer as well. Now you can see there is this silver wire in contact with 3 moles per decimeters cube concentrated potassium chloride solution, and there's a section of the silver wire that is coated with silver chloride, and there's a section of the silver wire that is not coated with silver chloride. Both of these sections are in contact with our 3 moles per decimeters cube concentrated potassium chloride solution. So when you want to use this standard silver chloride reference electrode, you can connect the secondary electrode that you want to measure the electrode potential of using this exposed region of our silver wire onto the secondary electrode. Now students, we have successfully prepared a silver chloride standard reference electrode. So this is a secondary reference electrode, and this silver chloride standard reference electrode was prepared by using a silver wire that was coated with silver chloride, and we used a glass tubing. One end of the glass tubing was sealed off using a small bit of agar gel, and this agar gel will act as a salt bridge when we are using this particular electrode, and the top end of the silver electrode was sealed off with the use of some adhesive and silicone sealer. So usually silver electrodes are used in conjunction with another electrode to measure the electrode potential of the second electrode you are using. So the electrode potential of a standard silver electrode or silver chloride electrode is going to be known to us when we are using such a reference electrode. Based on the concentration of the potassium chloride solution within this solution, the electrode potential of this standard reference electrode will vary. At this point, we have used 3 moles per decimeters cube concentrated potassium chloride solution. So therefore, this specific standard reference electrode that we have made here will have an electrode potential of 0.210 volts. So this particular electrode potential is going to be stable while we use this electrode to measure the electrode potential of another electrode. So due to its compact nature, and due to the ease of use that revolve around silver chloride reference electrode, we use this in many of our potentiometric analysis. Usually, the silver electrodes are always used in conjunction with another electrode because we use this as a reference electrode. That means we will always use this in conjunction with another electrode. So students, that is all when it comes to preparing or making a standard silver chloride reference electrode. This is also known as a metal insoluble salt electrode, and this particular type of reference electrodes are known as a secondary reference electrode. Primary reference electrode is going to be our standard hydrogen electrode, where we take the electrode potential to be 0. However, when it comes to secondary reference electrodes, electrode potential of these types of electrodes are not 0. The electrode potential of secondary reference electrodes are not going to be 0. It is going to be a very stable electrode potential, so we can use it to measure the electrode potentials of other electrodes. Now we have learned how to prepare silver chloride reference electrode. Now let's go over the summary of today's experiment. When we started off this particular experiment by cleaning the silver wire. To clean the silver wire, we can use a physical method as well as a chemical method. So the physical method was to sand the silver wire with a sandpaper, so that when you sand the silver wire, any coating that is on the silver wire will be removed, or any other impurities will be taken off, so the silver metal will be exposed to the surface. Then we reacted it with nitric acid. If there were any other impurities on the surface of the silver metal, then it will be removed. Afterwards, we washed off the silver metal with distilled water, making sure that the silver metal is exposed to the surface now. And then we proceeded to coating the silver metal with silver chloride. So we carried out this process by electrolyzing a solution of dilute potassium chloride. So we connected the silver wire to the positive terminal of the direct current supply, and we connected a graphite rod onto the negative terminal of the direct current supply, and then we immersed these two electrodes in our electrolyte solution, which is potassium chloride. So at this point, we observed that the immersed section of the silver wire was turning a dark brown color. This is because as silver ions are removed from the silver metal, they come into contact with the chloride ions in the medium, and they will turn into silver chloride on the surface of the silver metal that is immersed in our electrolyte solution. And at the negative terminal, we saw hydrogen received electrons and turned into hydrogen gas. So we could see formation of gas bubbles at the negative terminal, indicating that the reaction is proceeding properly. So after coating a section of the silver wire with silver chloride, we moved on to taking a glass tube that is cleaned, and then we took that glass tube, and one end of the glass tube was sealed with agar gel, and this agar gel was prepared by dissolving agar powder with 3 moles per decimeter cube concentrated potassium chloride solution. So this particular small membrane or small layer of agar gel that we have here on this glass tube is going to act as a solid internal electrolyte as well as ion diffusion membrane, or in other words, it can also act as a salt bridge when we are using this particular silver chloride reference electrode. And the tube after that was filled with 3 moles per decimeter cube concentrated potassium chloride solution, and then We inserted the silver wire. After that, we sealed off the top end of this glass tube with the use of some adhesive and silicone sealer, making sure a small section of the wire comes out of the electrode so that we can connect it to another electrode with the use of another wire. So students, that's how we prepare our standard reference electrode, which is silver chloride reference electrode. So now you know all the steps to prepare such an electrode. One of the reasons why we prefer this electrode over the standard hydrogen electrode is because it is very easy to use compared to the standard hydrogen electrode, and is very compact. So this is easy to use, and we use it quite often when it comes to our potentiometric analysis in the lab. So students, that will be all for the main part of this experiment.